All right, and we're now recording. Okay, so technically I've already given you everything I needed to give you for the exam. I'm just going to go back over some stuff. So let's take a look. Right, so last time I did sum of 12.3, sum of 13.2. Today I'll do 12.3 and 13.2 also. Okay, and then we're finished. Okay, and then if anybody wants to ask questions, they can ask questions, and if not, we're done. Okay, so 12.3, 13.2 last Thursday, 12.3, 13.2 today. Okay, so our last regular exam is Thursday. The usual requirement that you have to submit at least 70% of the homework from here. And as usual, once class is over today, if you want to start turning the homework, you may, but otherwise you have until half an hour after the exam to submit your homework. Okay, so Thursday, I'll start with questions and answers, and then up to 6 o'clock. And if that stops, or if nobody has any questions, we can just start earlier, and then you have more time for the test. Okay, then Tuesday the 18th will be our final review. Okay, I'll basically just go back over all the previous exams, and that's how you study for the final exam. Study the final exam by just looking at the previous exams. And then our final exam is on the 20th. That's all we're going to do that day. No questions and answers on the 20th. We'll just go straight to the final exam. And there's no homework that you have to turn in for the final exam. I know you're used to submitting homework, but there's no homework for the final exam. Okay. So study the old exams. For cheat sheets, you can have all the cheat sheets from the previous exams. So hopefully you didn't throw away the cheat sheet, formula sheet from a first test, second test, third test, fourth test, fifth test. Again, don't reinvent the wheel. You got them all, just bring them all together. So let's say you can have 5 formula sheets for the final exam. If you lost it, you threw it away, you can reconstruct a new one. If you say to yourself, oh, I wish I put something on the second formula sheet, you can put it now. You can go back and add stuff. That's always allowed. Okay. So I'll do some more problems from 12.3 and 13.2. And then if I finish early, which I think I will, then I'll let you ask questions. And then when that stops, we can just call it a day, and that'll be it. And you can still ask questions at the beginning of next time before we take the exam. Okay. All right, let me check the chat for questions. Some of you marked down, okay, that you were here. Okay. All right. So let me go right to lecture, which is going back and doing some more 12.3 and 13.2. Okay. And think of any questions you might have in preparation for the test. Okay, so back to 12.3, number 22. Okay, so again, I stopped for a certain point from 12.3, so I can go to 13.2. So I kind of did a half job on 12.3 and 13.2. Okay, so it's the integral of 7x squared over 4x cubed minus 9 dx. So again, technically today, there's nothing new. I'm just going back over some problems that I introduced last time. Okay, so I noticed the derivative of the bottom is probably close to the top. And you say, how do you know that? Because this is x cubed. The derivative of something with an x cubed is an x squared. Okay, so let u be the bottom. U equals 4x cubed minus 9, whose derivative is 12x squared dx. Okay, there's the x squared. This is dx. There's a 7 that's kind of in the way, so just take out the 7. I need to have a 12. So I put a 12 inside and a 1/12 outside. Okay, so overall, I'm going to have a 7 over 12 in front, integral of 12x squared dx, everything circled here, 12x squared dx, that's my du, divided by u, 4x cubed minus 9. Okay, again, I sneak in a 1 if that helps you. If you can't read it, that's a 1. 1 over u, then I say, okay, that's my natural log. So 7/12 natural log, absolute value of u plus c. And then just change u back to what it was. It was 4x cubed minus 9. So final answer is 7/12 ln absolute value of 4x cubed minus 9 plus c. Okay. 24, 5x squared over 3x cubed minus 8 dx. Very, very similar. This is cubic. This is squared. The derivative of a cubic is a squared. So again, let u be the bottom. So u equals 3x cubed minus 8. du is 9x squared dx. Okay, once again, that 5 is kind of useless. Just take it out. So 5 is in front. I need a 9, so 9 inside, 1/9 outside. So that gives me overall 5 times 1/9, which is 5/9. And then 9x squared dx. 9x squared dx is my du divided by u. Okay, so that gives me 5/9 natural log absolute value of u plus c. Change u back to what it was. It was 3x cubed minus 8. So final answer, 5/9 ln absolute value of 3x cubed minus 8 plus c. Okay, and quick reminder, can this thing ever be negative? Sure, if x is 0, so you need the bars. Can this thing ever be 0? Yes, x is 0. Leave the bars. Okay, so, but we saw last time if there was a possibility, or sorry, there was no possibility of the expression inside the bars being negative, then take off the bars and make them parentheses. Okay. Okay, 28. Again, notice these are indefinite integrals. That means there's no numbers here and here. So your answer is blah, blah, blah plus c. 13.2, they were definite integrals like this. So your answer is going to be a definite number. Okay, 28. The original was x plus 2 over x squared plus 4x minus 9 dx. Okay, again, the derivative of the bottom is probably close to the top. So how do you know that? Because it's second degree. The top is first degree. X squared plus 4x minus 9, second degree. Top is x plus 2, first degree. So let u be the bottom. U is x squared plus 4x minus 9. Du is 2x plus 4 dx. And I notice if I factor out a 2, I get 2 times x plus 2 dx. And I see a x plus 2 here. So I need a 2, right? So I had to do a little bit of algebra to tell me what I needed, right? So 2x plus 4 is 2 parentheses x plus 2 dx. And the original was like this, right? So, oh, x plus 2 dx. So there's a 2 there. So I have to put a 2 inside, 1/2 outside. Okay, so now everything's circled here in green. 2x plus 2 dx. 2x plus 2 dx is my du. And the bottom is u. All right, so I have 1/2 from there, integral of du over u. So that's 1/2 natural log absolute value of u plus c. And then change u back. U was x squared plus 4x minus 9. So 1/2 natural log absolute value of x squared plus 4x minus 9 plus c. And there we go. Okay, then jumping back to problem 12, or the 12 that was in the book, integral of 4 over e to the 1 minus 2x dx. Okay, the first thing I notice is I don't want an e in the bottom, so I have to bring it up. In order to bring it up, I put a negative in front of the exponent. So 4e to the negative 1 minus 2x. A little bit of algebra, that makes that 2x minus 1. Okay, that's negative 1 plus 2x, or 2x minus 1. Okay, then I can do my substitution. Let u equal 2x minus 1. Du equals 2 dx. Okay, take the 4 outside. I need a 2 inside, so multiply inside by 2 and 1/2 outside. Okay, so the next step, that's going to be my u. That's going to be my du. Outside I have a 1/2 times 4, which is 2. So I now have 2 times the integral of e to the u du. Okay, so 2 e to the u plus c. Okay, then just change u back to what it was. U was 2x minus 1. So final answer, 2 e to the 2x minus 1 plus a constant. And there we go. Okay, so that's some more problems from 12.3. Now I'm going to go back and turn my attention to 13.2, which are definite integrals. Okay, so there are numbers here and here. So we still do a lot of the same stuff. We integrate, except you don't need to see. Remember, and the funny looking S moves over to the right side. You plug in the top and you plug in the bottom. Okay, so 13.2, my number 20. And originally, ignore all the red. 5x squared, 4x cubed minus 2 to the 4th power dx. Okay, and we know the derivative of 4x cubed minus 2 is going to be something with an x squared. Okay, that always tells me how to substitute, right? 3rd degree, 2nd degree. So if I let this be u, let u be 4x cubed minus 2. The derivative is 12x squared dx, and there's the x squared. Okay, the 5, again, doesn't serve any purpose, except I'll just bring it outside. There's x squared, there's dx, x squared dx. I need to have a 12. So 12 inside, 1/12 outside. Okay, so I'm going to have 5/12 integral. That's u to the 4th, 12x squared dx, du. Okay, one thing that's a little bit tricky, you shouldn't just leave it as 0 to 1. 0 to 1, right here, it's understood that it's for x. I'm still going to leave the 0 and a 1, but when you switch over to u to the 4th du, if I don't put the x equals, you might think, oh, when I'm integrate, I just plug in 0 and 1, but you don't. Okay, because that's still for x. So that's why I'm still putting, and you should also put x equals 0, x equals 1, because if I don't put that, the understanding here is that 0 and 1 are going to be plugged in for u, and that's not true. It has to be for x. Because we have to keep that in mind when we substitute. All right, so I have 5/12 u to the 5th over 5, x equals 0 to x equals 1. Again, you can't just leave it as 0 and 1, because otherwise you might think you should just plug it in here. Okay, 5 cancels out, that gives me 1/12. Okay, now I change u back to what it was. U was 4x cubed minus 2. So 4x cubed minus 2 to the 5th power. Now I can just put 0 to 1. You don't have to put x equals anymore, although it's not wrong if you do. It's obvious 0 and 1 are for x. There's no other letter. There is no w, there's no t. It's clearly 0 to 1. So please notice that temporarily write x equals when you switch over to u. Okay, u, so you need x equals, u, x equals, but when you substitute back, you don't need to put x equals anymore. It's understood in this case. Okay, so you have 1/12, and looks like I messed up the first time I did this. So I plug in, let's see, what am I supposed to do? Yeah, I plug in 1. So I have 4 minus 2, 2 to the 5th power, minus, plug in 0, I have -2 to the 5th power. Ignore all this stuff I messed up. So that's going to be 32 minus a -32 times 1/12, 64 over 12, 16 over 3. Okay. Okay, problem 24. Temporarily ignore all the red. Integral from 0 to 4, 3x squared minus 2 to the 4th power times x dx. This is 2nd degree. This is 1st degree. So the derivative of this is probably close to that. So u equals 3x squared minus 2. du equals 6x dx. I need a 6. 6 inside, 1/6 outside. So the next step, that's going to be u to the 4th. 6x dx is du, 1/6 outside. And again, notice I'm putting x equals 0, x equals 4. You should do likewise, because if you don't, right, if I just leave it like this, the understanding is, oh, the 0 and a 4 must be for u, but it isn't. It's for x. Okay, so there's a couple steps where you have to put x equals. Okay, 1/6, u to the 5th over 5, x equals 0, x equals 4. Again, if you don't put it, you might accidentally plug in here and you're not supposed to. Not until you substitute back can you not put the x equals. Okay, what was u? 3x squared minus 2. So I now have 1 over 6 times 5 is 1/30th. 3x squared minus 2 to the 5th power. Now you don't have to write the x equals anymore if you don't want to. Although it's not wrong if you do. You know, it's obvious because that's the only letter that you see here. Okay, so you have 1/30th. Plug in 4. Okay, this gets real big. 4 squared is 16. 3 times 16 minus 2 to the 5th power minus, okay, plug in 0. 3 times 0 minus 2 is negative 2. So you plug in 4, plug in 0. Okay, this is super big. Use your calculator for this. So 3 times 16 is 48, minus 2 is 46. 46 to the 5th power, yeah, it's a big number, minus negative 2 to the 5th power is negative 32. Okay, so I punch it in my calculator. 6865433.6. Okay, so you can punch it out as well as I can, but that's what it comes out to be. Okay, and I think I'm finished on this page. Let me do my focusing thing again quickly. And that. Okay. Okay, then 26. Integral from 0 to 2 of the cube root of 2x cubed minus 8 times x squared dx. Okay, so the thing I have encircled in red, 2x cubed minus 8, its derivative is going to be pretty close to x squared. So that tells me how to substitute. That u be this. U equals 2x cubed minus 8. Du is 6x squared dx. So that's going to be his cube root of u. There's the x squared, there's a dx, there's no 6, so put 6 inside, 1/6 outside. So instead of cube root of this mess, I got cube root of u. 6x squared dx du. So my new integral is 1/6 integral as x goes from 0 to 2. So again, you have to write that. Cube root of u means u to the 1/3. X equals x equals. All right, so add 1, u to the 4/3 divided by 4/3 means times 3/4. Okay, so I have 3/4 u to the 4/3. Still x equals 0 to 2 because I haven't substituted back yet. And there's a 1/6 out in front. Okay, a little bit of cancellation. 3 divided by 6 is 1/2. And multiplied by 4, so I have 1/8. So my coefficient is 1/8. Change u back to what it was, 2x cubed minus 8 to the 4/3 power. So 1/8, plug in 2. And yeah, now that I switch back to the original x, I don't have to put x equals anymore. Okay, plug in 2. 2 cubed is 8. 8 times 2 is 16. 16 minus 8 is 8. So 8 to the 4/3 minus, plug in 0. 0 minus 8, so negative 8 to the 4/3. Okay. This means power root. Power root. So I do the cube root of 8, 2, raised to the 4th power, 16. This means cube root of negative 8, negative 2. And then negative 2 to the 4th power, negative 2 times negative 2 times negative 2 times negative 2 is also 16. So I have 1/8 of 0, 0. Okay. Okay, number 30. Integral from 1 to 5e of 3y to the negative 1 dy. Okay, you have to watch out for this kind of problem. Do not go y to the 0 over 0. Okay, that itself should already tell you, hey, I'm not supposed to divide by 0, right? And in fact, you remember when we have the power root, long time ago when you had the power root, right? Integral of x to the n dx is x to the n plus 1 over n plus 1 plus c. You might recall we said n was not allowed to be -1 because then you'll be divided by 0. So what do you do if you have a -1? So you can't go y to the 0 over 0. Instead, you should say to yourself, oh, that's 1 over y. 3 times 1 over y. That's my natural log. So it's 3 ln absolute value of y from 1 to 5e. Plug in 5e. Natural log of 5e is 5e, it's positive. Plug in 1, absolute value of 1 is 1, and ln of 1 is 0. So final answer is just 3 ln of 5e. Okay. All right, so that's it for that. Okay, I'm sort of done, folks. I did get some prior requests for some other problems, so I'll go ahead and do a lot of other problems since we have the time. It's only a little bit after 5. So I'll do some requests now. So some of you may have had questions with some of these, so I might be answering some of them anyway. Okay. Go back and do so. If some of you have some questions, I may answer some of them now. Okay, so problem 28 from 12.3 looks like this. Integral of 2x to the 4th plus 3 squared, 8x dx. Okay. All right, this one you cannot substitute because the derivative of 2x to the 4th plus 3 is going to be something cubed, but I don't have it here. So I cannot substitute. So what do? Just multiply it out. So 2x to the 4th plus 3 squared, that looks like this, right? A plus b squared, a squared plus 2ab plus b squared. Okay, so I square this. 2x to the 4th squared is 4x to the 8th plus 2ab. 2 times 2x to the 4th times 3 is 12x to the 4th plus 9. And then times 8x dx. And distribute all this stuff. So 4x to the 8th times 8x is 32x to the 9th. 12x to the 4th times 8x, 96x to the 5th. Plus 72x dx. Okay. So that's how you do that one. All right, so 32x to the 10th over 10th plus 96 x to the 6th over 6 plus 72. Remember, x is like x to the 1. 72 x squared over 2. Simplify. See, I took out a 2 here. So 16 over 5 x to the 10th plus 16 x to the 6th plus 36 x squared plus a constant c. Okay, had a request for 13.222. Okay, so the original was like this: integral from 0 to 3 of 2x minus x squared to the 4th power times 1 minus x dx. The derivative of this looks like it might be that, right? Second degree, first degree. Okay, so let u equal 2x minus x squared. The derivative is 2 minus 2x dx. Factor out the 2, I have 2 times 1 minus x dx. There's the 1 minus x. There's the dx. Missing a 2. So 2 inside, 1/2 outside. So the integral is 1/2. And again, when I substitute over to u, you need x equals 0, x equals 3. Okay, so instead of blah, blah, blah to the 4th power, it's u to the 4th power. Just replace that with that. 2 times 1 minus x dx is now my du. Okay, so 1/2 u to the 5th over 5. X goes from 0 to 3. Okay, that becomes 1/10. Change u back. What was u? 2x minus x squared to the 5th power. Now I don't have to write the x equals anymore because it's obvious. Okay, and by the way, notice when you plug in 0, you get 0, right? 2 times 0, 0, 0, square root of 0. So that's 0, that's easy. The harder part is 3. So if we plug in 3, I have 1/10. 2 times 3 is 6, minus 3 squared is 9. Minus nothing, so ignore that. Negative 3 to the 5th power. So negative 243 over 10. Okay, yeah, I got a request for some problems in the book. I'll show that to you as soon as I finish this page, so I don't lose my train of thought, I guess. Okay, so that's that. Okay, 28 from 13.2. Integral from 0 to 2 of e to the 4x minus 3 dx. Okay, and I say to myself, I don't want 4x minus 3, I want u. So let u equal 4x minus 3. What's the derivative of 4x minus 3? 4. So du equals 4x dx. I don't have a 4. Put in a 4. 1/4 outside. So I now have 1/4. E to the 4x minus 3 is now e to the u. See, we're making the problem easier by doing the substitution. And then 4 dx is du. And I need to write x equals 0, x equals 2. Because if I don't, 0, 2, the understanding is that those are going to be for the letter u, but it isn't, it's for x. Okay, integrate. The integral of e to the u is still e to the u. So I have 1/4 e to the u. Again, the funny looking s moves over to the right side, straighten out. Still x equals 0 to 2. Now change u back to 4x minus 3. And now that it's 4x minus 3, I don't have to write x equals anymore. Although it's not wrong if you do. Okay, factor out to 1/4. Okay, plug in 2. 4 times 2 is 8, minus 3 is 5. So e to the 5th minus plug in 0, e to negative 3. And you can leave it like that. 1/4 of e to the 5th minus e to the negative 3. Okay, then one more on this page is number 8. And let me just check quickly if I have anything else here. And I don't think I do. Yeah, pretty much going to be it. Okay, 24 w to the negative 2 dw. It's kind of weird to use w, but anyway, it's there. Negative 2 to negative 1. Okay, I don't need to substitute. I can just go right to it. 24 w to the negative 1 over negative 1 from negative 2 to negative 1. Okay, let's change this to negative 24 times 1 over w. Better for algebra, right? To make it as 1 over w. So I got negatives all over the place, unfortunately. Leave the negative 24 out of it, factor out the negative 24. So it's 1 over negative 1 minus, plug in negative 2, 1 over negative 2, negative 1/2. So it's negative 24 times negative 1 plus 1/2, which is negative 1/2. Negative 1 plus 1/2 is negative 1/2. And negative 24 times negative 1/2 is positive 12. Okay, so the final answer looks like it's 12. Okay, so let me do the focus thing on this. I've got one more page to show you. And somebody requested some pages. So let me show that to you quickly. And there's that. Okay, so I only had one more page left, folks. So as soon as I finish that, I'm done. And then if anybody wants to ask questions, you may, but if not, we're dismissed. Okay, so again, you can still ask questions next time if you wish. Homework that you're supposed to turn in is everything here. Okay, So at the start of class next time, question and answers, and then when that stops, we go straight to the exam up until a maximum of 5 o'clock at the latest. Okay. And let's see, let me check the chat. 12.3, 24 to 30. So let's show what that was. .3, 24 to 30. 12.3, 24 to 30. And unfortunately, it may not even match what I had, but the problems are close. And again, you're still learning how to do stuff. So I think that's what you need right there. And sorry, I can't hold it that long because the book's heavy, but you can watch the video later if you want to catch that. Okay. All right. Okay, it's not quite about 5:15. I have about 1, 2, 3, 4 more problems to do, and then I'm finished. So if you have any questions, start thinking of putting them, or you can start writing them in the chat now, even if you wish. Okay, 13.2, number 12 was asked for. Integral from 0 to 2 of x to the 4th minus 5x cubed plus 2x dx. Okay, I don't need to substitute. 5x to the 5th over 5 minus 5x to the 4th over 4. Okay, some of you recognize this right away. The integral of 2x is x squared. Okay, now if you don't see that right away, I wrote here in scratch paper 2x to the 1, right? So it's 2x squared over 2. 2 cancels out x squared. Okay, 0 to 2 migrates to the right side, 0 to 2. Remember, you can always double check by taking the derivative, right? What's the derivative of this? 5 comes down, knocks out that 5, you have x to the 4th. Minus 4 comes down, knocks out that 4, 5x cubed. Derivative of x squared is 2x, perfect. From 0 to 2. Okay, very conveniently, when you plug in 0, quite often you get 0, right? Plug in 0, that's 0, 0, 0. 0 to the 5th is 0, 0 to the 4th is 0, 0 squared is 0. 0 divided by 5 is 0, 5/4 of 0, 0, 0 minus 0 is 0, right? So the only thing of substance is the 2. Okay, 2 to the 5th power is 32. 32 over 5 minus 5 times 2 to the 4th power is 16 divided by 4 plus 2 squared is 4. And 16 divided by 4 is 4. So I have 32 over 5 minus 20 plus 4. Negative 20 plus 4 is negative 16. Common denominator is 5. Multiplied by 5, multiplied by 5. 32 minus 16 times 5 is 80 over 5. Negative 48 over 5 is my answer. And yes, an integral can come out negative, and we know what that means now, right? The graph spends more time below the x-axis than above the x-axis, evidently. Okay, question about 24. So integral from 1 to 2 of 5 over z cubed dz. Okay, again, don't worry about the letter. X dx, z dz, w dw, it's all the same. Okay, before you integrate, that has to come upstairs. It can't be in the denominator. So 5z to the negative 3rd dz. Then I can do the power rule. So that's 5z to the negative 2 over negative 2 from 1 to 2. Okay, that gives me negative 5 halves times z to negative 2 is 1 over z squared, right? So we get 1 over z squared from 1 to 2. So you have negative 5 halves. Okay, so plug in 2. I have 1/4 minus 1. So 1/4 minus 1 is a negative 3/4. Negative 5 halves times a negative 3/4. Final answer is 15 over 8. Okay, going way back to 12.1. Somebody asked about something in 12.1 and also 12.2. Okay, it was x plus 1 over x cubed. integrate x plus 1 over x cubed. That's a quotient. How come I don't do a quotient root? There is no quotient root. So I just divide. X divided by x cubed is 1 over x squared. Plus 1 over x cubed, well, it's just 1 over x cubed. This is an indefinite integral. So what's the answer look like? Blah, blah, blah plus c. Okay, so this is x at a negative 2 plus x at a negative 3 dx. All right, so x at negative 1 over negative 1 plus x at negative 2 over negative 2 plus c. The original problem did not have any negative exponents, so I should not leave the answer with negative exponents. So negative 1 over x minus 1 over 2x squared plus c. Okay, finally, I had a question about 12.221, and then I'm finished, folks. Okay, and so only about 5:20-ish. Okay, so if you have any other questions about the test, ask them now. Either be ready to unmute yourself or put it in the chat. You can put it in the chat even now. I'll be done in a few minutes. And if not, we're done. Okay. And then, yeah, after we dismiss, you can start sending the homework if you wish. Okay, so Thursday, last regular test. Next Tuesday, we'll review for the final. Then the following Thursday, final exam, and we're done for the course. Okay. Okay, 12.221. The original had 2 x cubed minus 1, x to the 4th minus 4x plus 3 to the negative 5 power dx. Okay, I notice this is 4th degree. This is 3rd degree. The derivative of a 4th degree is probably a 3rd degree. So let u be x to the 4th minus 4x plus 3. What is the derivative of this? 4x cubed minus 4 dx. Now I look at what I had, x cubed minus 1. Well, if I factor out a 4 here, 4 parentheses x cubed minus 1. So I have what I want essentially. So x cubed minus 1 dx. I need a 4 inside, so 1/4 outside. All right, so outside I have a 1/4 and a 2. 2 times 1/4 is 1/2. Integral x to the 4th minus 4x plus 3 to the negative 5, u to the negative 5. 4 x cubed minus 1 dx du. Indefinite integral. There's no numbers here, so my answer involves a plus c. So 1/2 u to the minus 4 over minus 4 plus c. Am I allowed to leave my answer with a negative exponent? Yes. So 1 over 2 times negative 4, negative 1/8. X to the 4th minus 4x plus 3 to the negative 4th power plus c. And that's my final answer. And there we go. Okay, so I'm done, folks, and I've answered all the questions that were previously asked. So if anybody wants to ask any questions now, you may. Let me just do my focus thing right here, and then I'll check the chat. And if not, we're finished. Give you this. And that. And that's it for that. Okay. All right. So I do see something in the chat. Let's take a look at what we have. Does the final have 10 questions, 1 question each chapter? Okay, most likely for the final exam, I think we said it's going to be around 15 questions, 3 from each of the previous exams. Okay. Since you have the entire time, which is, well, time and a half. So I'll give you an exam, which is time and a half. So about 15 questions. Okay, so most likely I'll pick 3 questions from each test in constructing the final exam. Okay. All right, anybody else with a question? Otherwise, we're done. Okay, you can still ask questions next time, but it's more efficient if you ask today, then you have more time to do the test. But again, next time, if nobody asks a question, which has happened in previous exams, we can just start the test right away. Okay, so exam 5, Tuesday, review for the final, and Thursday, the final. Just study the old exams. So as soon as the test is over on Thursday, go back and review the previous exams, and I'll spend all of Tuesday of next week for doing that also. Okay, final exam, you get 5 cheat sheets. Okay, 1 for each of the previous. So the cheat sheet you had for each test, just bring them in, as long as you still have it. If you don't have it, make it up again. Okay, so if you still have the first cheat sheet for the first test, and the second, and the third, and fourth, and fifth, you got it. Just bring them all in. Okay, and again, if you want to add to it, you may. So 5 formula sheets are allowed for the final exam. Okay, not for this next test. Thursday's test is a usual test, so just 1 formula sheet. Usual rules. You have to turn in this homework. You can turn it in now as soon as we finish. But again, the usual rules, if you don't, you can have until half an hour after we finish the test to submit the homework, just like any other regular test. Okay, anybody else, please? You can always email me for questions too. Wait just a moment longer in case anybody's typing. All right, I don't see or hear anything else. All right, so we're done, folks. If you want to start submitting the homework, you may, and we'll see you next time for the test on Thursday. All right. Okay, have a good night, everybody. See you.
Thank you.
Bye.
Thank
Thank
you.
you.
Thank you.